Assalamu alaikum and greeting to all. We are Group 10, Section 3, Engineering, Geology and Rock Mechanics. Today we'll speak about type of rock, specifically sedimentary rocks. My name is Muhammad Mahmoud El-Wafa Ahmad and these are my group members. You already have some knowledge of sedimentary rock classification as sandstone, limestone, duststone, siltstone, shell, breccia, conglomerate, coal. However, if you devote enough time to reading and learning, you will be able, when discussing these many sorts of rocks, you will quickly discover that there is no categorization scheme for them. And more troublingly, there are numerous phrases that signify the same thing. In this video, I will walk you through various different classification systems for sedimentary rocks, as well as help you to understand some potentially complex terminology. Let's get started. Separating clastic and non-clastic rocks is one of the simplest ways to classify a rock. A clast is lithogenous sediment particle or grain that formed by weathering and erosion of pre-existing rock. As a result, terms clastic and clastic are occasionally used interchangeably. Detritus sediment, and lithic fragment. Clastic range in size from large powders to little bubbles. Particles the size of clay that can only be seen with advanced electronic microscopes. In any event, evidence for grain created by weathering and erosion may be seen in clastic sedimentary rock if you look attentively. Non-clastic rock, unsurprisingly, don't have grains in them.
Carbonate rocks. However, in the case of carbonate rock, the difference between clastic and non-clastic rock is not always evident. Calcite and dolomite. Carbonate rocks are made up of minerals that contain the carbonate and iron, such as calcite, aragonite, and dolomite. Limestone and dolostone. Limestone and dolostone are the two primary forms of carbonate rock. Non-clastic limestone. Some carbonate rocks are not clastic at all. Mitrite. Some limestone, for example, are made completely of mitrite. Mitrite are the calcium carbonate particles of a diameter of smaller than 4 micron or 4 micrometer.
These particles form through chemical reaction in water. In other words, mercury is a type of hydrogenous sediment. But some carbonate rocks consist of one or more types of clasts. Generally speaking, we can sit between three types of clasts. Lithoclasts fit the classic definition of clast. They are heterogeneous sediment derived from pre-existing rocks. In the case of limestone, a lithoclast is a reworked carbonated fragment usually derived from pre-existing rocks with sizes greater than 2 millimeters. Bioclasts are particles, grains, or pieces of organisms, such as fragments of shells or bone. Put another way, bioclasts are grains of biogenous sediment, seashells, which are made of calcite and aragonite, are common bioclasts in clastic limestone. You will also sometimes see the term interclass. Interclasts are irregularly shaped grains that formed from erosion of partially lifted or soft sediment Interclasts can be litigious sediment, biogenous sediment, hydrogenous sediment, or some combinations of all the above. A specific example of interclasts are called web-up clasts. Web-up clasts are gravel-sized pieces of clay or mud that are created when erosional event removes pieces of clay-rich sediment and transports them some distance. Because clay sticks together and it's cohesive, the pieces can be transported and preserved when they are finally deposited in a place. In any case, carbonate rocks are neither clastic nor non-clastic. They are sometimes in between. For this reason, carbonate rocks are usually treated as one of a number of different categories. One of the other most important categories of sedimentary rocks is sometimes called trigonous. Trigonous rocks include precious conglomerates, sandstones, siltstones, and mudstones and shales, although they sometimes contain eugenous or hydrogenous sediment. The textbook examples of these rocks are made almost entirely of lithic fragments of igneous, metamorphic, and other sedimentary rocks, so they consist of lithogenous sediment and are definitely clastic rocks.
Regions is the scientific name for them, since they are made up of several classes produced from the earthworking and erosion. However, you will frequently hear them referred to as something else, siliciclastic. This is due to the fact that the regions rock are virtually completely made up of silica, in the form of silicate minerals like quartz, feldspar, and mica and clay. By far, terrigenous and carbonate rock are the most common type of sedimentary rock. Terrigenous rock make up around 80 to 85% of all sedimentary rock in terms of value. Carbonate rock proved for additional 10 to 15 of the sedimentary rock value. In the crust, however, doesn't include other forms of sedimentary rock aren't important. Volcanic plastic rock being another significant category of sedimentary rock. Volcanic plastic rock, as the name implies, are made up of clastic created by volcanoes, which refers to debris implied violently by volcanoes. Volcanoclastic encompasses all types of detritus generated by volcanoes. As a result, it is the more inclusive and popular term. Volcanic eruptions create both igneous and sedimentary rock, which must be understood. Volcanoes frequently emit magma in the form of molten lava, which can cool and solidify as extrusive igneous rock. For example, basalt. However, when volcanoes erupt violently, they also expel a range of other material known as tufa. Tufa is made up of several different elements, including volcanic ash. Volcanic ash relates to the igneous rock class, as well as volcanic glass particles and grains, as well as amorphous and non-crystalline material formed by quake magma cooling. Tufa also comprises significantly bigger lithic bases that were thrown as cold black or partially molten chunks of magma from the volcano.
After a soft tephra becomes hard, sedimentary rock through the process of lithification, and that we call it a tuff. A tuff is a type of volcanoclastic rock. Overall, volcanic clastic rocks are clastic rocks, consisting of various fragments of igneous rocks and glassy minerals. There are a number of other important types of sedimentary rocks. These include amber, coal, phosphorite, chert, evaporite, and ironstone, among others. Although all of these rocks are non-clastic, they form under very different circumstances. For amber and coal only form in the presence of life in environments where plants provide biogeneous sediments and biogenic materials. For evaporate and constraint doesn't require the presence of life. Whatever, it consists of hydrogenous sediments produced by natural chemical reactions. For the rest, chert, phosphorite, and ironstone can also form from hydrogenous sediments in the absence of life. That said, it's known that life forms play critical roles in the formation of all of these rocks. And it's helpful to think about these sedimentary rocks collectively as a loose category of biochemical rocks, chemical reactions, including reaction catalyzed by living organisms, are necessary for the formation of all of these rocks. In summation, classifying sedimentary rocks is somehow very messy. There's no perfect way to do it. We just have to recognize that some rocks may be similar in one way and different in another. And as a rule, whenever you think about a rock, you need to be mindful that it might be actually a peanut butter sweet, not entirely chocolate and not entirely peanut butter, something in between. With moving forward, you should concentrate on committing these sedimentary rocks to memory, learning how to identify them by sights, feel and understand the circumstances under which they are deposited.
Finally, I hope you enjoyed watching and thank you for your attention.